Okay, here's a video about solving a second order linear non-homogeneous differential equation by the method of undetermined coefficients. And the way that it would work for something like this is that the general solution takes this form. Y sub c is the general solution to the complementary homogeneous equation with respect to that one. And yp is a particular solution to the original non-homogeneous. And you can find that by the method of undetermined coefficients, which is what we'll do now. Or I'll solve this same problem in another video with this other method of variation of parameters. Okay, so the way that we would proceed if we're going to do this is I would make the first step to find y sub c, okay? And to do that, we would consider that was our problem, this homogeneous equation. And the way that we proceed is to solve the characteristic equation. And that's going to be r squared minus 1 is equal to 0. Okay, that's easy to solve. We'll get r to be 1 or negative 1. And we'll get this straight from that as some constant c1 times e to the t power plus some other constant e2 times e to the minus 1 power. Okay, so fairly simple and straightforward for solving a homogeneous second order differential equation. Now for the second part about finding y sub p, here's how we do that. We assume that this takes a certain form, all based on this original non-homogeneous element of our problem. And on the formula sheet or in a book, you can look up the guidelines for doing that. But here's what we'll find is you might say that it's got to look like this, but with some unknown coefficient. Hence the name, the method of undetermined coefficients. But it's a little more complicated than that. What this will be depends on if that number, this coefficient of t right here, is a solution to the characteristic equation or not. Okay? And I see that that's a 1, and this is a 1. And it's in fact true that 1 is a single root of this. So that's going to influence this choice, and in fact, that's not going to work. All right? Okay, so I wrote it down for your consideration, but here's what it would be. If I consult a textbook or our formula sheet, it's going to say that if 1, this number, is a single root of the characteristic, and it is. So that's a, some undetermined coefficient, times t e to the t. And from here, of course, we just need to make that work and be a solution to this original problem. So as part of doing that, I'll find y sub p prime, which I'll give to you this way by the product rule. Okay, there it is. And then y double prime, which I'll give it to you this way. Also by the product rule. Okay, and we could simplify this, but it's not really hard to work with that the way that it is. So I'll leave it like that, and I'll tell you what that differential equation would look like if this was the assumed solution. Okay, so y double prime minus y is equal to e to the t. Here's what that would be. We would get this. So here's my differential equation with this assumption. I'll get 2a e to the t power plus a t e to the t power, and then minus y. I'm assuming that this is the solution. Y is a function of t. So minus this. So it's going to look this way. A t e to the t. And that, to work, is going to have to be equal to this. Well, there it is. Well, that's not hard to handle. These two things cancel. I get like so. And it appears that that undetermined coefficient A has to be a half in order for this to be 1 and for that to be true. Okay. Well, so I've got my general solution. That's all I needed. Remember, it's going to be this plus that thing I just found right there. So here goes the all-important general solution. Is going to be like this. Y is a function of t. Some constant c1 e to the t power plus some other constant c2 e to the minus t plus 1/2 t e to the t power from that. So there's the general. Okay, so in the next video we'll talk about solving the exact same problem by variation of parameters. It's another method that has more flexibility to it. But we'll get the same answer, of course.